Hello, welcome to ANS Solver. This is the sixth question of the paper. So yeah, as you can see, the diagram shows the curve y equals to 8 plus x cube over 2 minus 5x. Okay, now the maximum point is denoted by m. This is the maximum point, which even shows that this is the stationary point. Okay, so now I need to find an expression for dy by dx and determine the gradient of the curve at the point where the curve crosses the x-axis. Okay, so first let's determine the dy by dx. So for this I use something called as the quotient rule. Why the quotient rule? Because a variable is divided by another variable. So I take my u as the numerator, which is 8 plus x cube, and I take my v as 2 minus 5x. Now I can take my u dash as basically the differentiation for 8 is 0 and the differentiation for x cube is 3x square. Now the differentiation for v dash is simply the differentiation for 2 is 0 and minus 5x is basically minus 5. So now I have the formula as vu dash minus uv dash over v square. So vu dash is simply 2 minus 5x into 3x square minus uv dash, which is minus 5 into 8 plus x cube, over v square, which is 2 minus 5x the whole square. Got it? So now I just need an expression in terms of dy by dx, and now I need to determine the curve or basically the gradient where the curve passes through the x-axis. So I can say dy by dx is equal to this. Okay, so now I need the gradient where it passes the x-axis. So if it passes the x-axis, I know my y is 0, obviously. When it passes the x-axis, my y needs to be 0. Okay, and I know the x I'll get is a negative because obviously. Okay, so I can say this 0 equals to 8 plus x cube over 2 minus 5x. So I can simply write this as x cube plus 8 equals to 0 and x cube equals to minus 8. Okay, so I can simply do the cube root of minus 8, correct, which I'll get as minus 2. So I know my x is minus 2. So now in this equation I can just put my x as minus 2. Okay, this is what I can do. Minus 5 into 8 plus minus 2 the whole cube over 2 minus 5 into minus 2 the whole square. So now I can simply solve this on the calc. So now what I can do is I can write this as 2 minus 5 into minus 2, okay, multiplied by 3 into minus 2 the whole square. Basically, yeah, you just need to copy this. It's not much of a task. Okay, it's simple calculations that on the calc you're doing it, which is okay because the calculator is allowed. So you can maximize the use of the calc. Just give me 1 second, I've been stuck. Okay, 8 plus minus 2 the whole cube, okay, over basically 2 minus 5 into this whole square. So when I solve this, I get my answer as 1, which is basically the gradient of this point when y is equal to 0, or when it crosses the x-axis, is 1. Okay, so now, yes, so this is the part 2 of the question. So I need to show that the x coordinate of m satisfies this equation. So now I know m, which I pointed out earlier, is a stationary point. And in a stationary point, my dy by dx is equal to 0. You need to know it. The gradient is always 0. So I can equate this to 0, which obviously if I multiply the denominator to 0, I'll lose my denominator. And now I can expand this. So when I expand this, I do 3x square into 2, which will give me 6x square. Then 3x square into minus 5x will give me minus 15x cube. Okay. Then I'll get plus 5 into 8 plus x cube here. Correct. So I can write this as 0 equals to 6x square minus 15x cube plus 40 plus 5x cube. Got it? So now I can basically write this as 0 equals to 6x square, okay, plus 40, and minus 15 plus 5 will give me minus 10x cube. So I can write this as 10x cube equals to 6x square plus 40. So now what I simply need to do is, I know I need an x here, correct, and I need a root. But I have an x cube here. So I can write this as 10x square into x, correct, which is 6x square by 40. Now what I can do is I can write this as x square equals to 6x square by 10 over x plus 40 by 10 over x. Correct? So I can write this as x square equals to, I can get this, and 6 over 10 will give me 0.6x plus, I can cancel the zeros here, and when I take x up, I'll get 4 into x raised to minus 1. So now I can write this as x equals to the square root of 0.6x plus 4 into x raised to minus 1, which is what we needed to prove. Okay? So needs, you need to be really good with your numbers or, algebra here to get your answer. Now, use an iterative formula based on equation in part 2 to find the x coordinate of m. Okay, so now my iterative formula is basically x. I can write this as x n plus 1 equals to root of 0.6 xn, okay, plus 4 with xn raised to minus 1. So now what I simply need to do is, let me take my n as 0. Okay, take your n as 0. So when you take as your n as 0, I get x1 with the root of 0.6 into x0 plus 4 into x0 raised to minus 1. Now a trick here, if you don't know what value to put as x0, just take it as 1, let's say. Okay, so because whatever value you take after some iterations, you'll get your correct answer. So now what you can do is, you can simply solve this on the calci. So write this as root of 0.6 into 1 plus 4 into 1 raised to minus 1. So when you do that, you get your answer as 2.144. I need to write everything to 5 significant figures. 448. Now for x2, what you simply need to do is, where you put 1, simply put the answer button. Remove 1 and put the answer button. So just click on the answer button. So when you do that, you get your answer as 1.7753. Now for x3, just click on equal to again to get 1.82161. Now your x4 to basically get as 1.8135. Now your x5 simply as 1.8149. Okay, your x6 as 1.8146. X7, okay, X7 when you do, you get 1.81467. Okay, so this is to 6 decimal place, 6 figures, I think. Yeah, so you can remove your 6 here and that is a 7. Okay, when you do your X8 also you get 1.8147, and your X9 also you get as 1.8147. Okay, after the answer button you just click on equal to equal to equal to. Now if you see, these three values here are recurring. Now if your values here are recurring, what you can simply do is, 1.81, okay, I think they have asked us to 3 significant figures, so 1.81 is the final answer. So basically any value you take as x0, you will land up with the same answer, which is 1.81. So yeah.